Alrighty. Okay. Hello, everyone. My name is Yadu. I'm on the Parsl team and the Globus Compute team. And today I'm going to be talking to you about MPI support in Parsl and Globus Compute coming. But I'll preface this talk by saying that this is less about what is already supported, already developed, and more about the fact that I need help, we need help on MPI. And I'll tell you exactly why we need help. So MPI, why is it so hard? So if you look at the programming model, the runtime system that Parsl has, the idea is that you go to a big machine when you're running lots of functions. What do you want to do? You go to the big machine, you request for a block of resources. You say, I want this many nodes. You provision those nodes, and as soon as you get them, what you do is you launch your manager, and then those managers capture the nodes, and then those managers will say, I've got this many cores, I'll put workers on them. So you capture all of the resources available, and then they all call back home, and they are ready to take on functions. In the workflow world, this is just called the pilot job model. You send out a pilot, which captures all the resources so that you don't have to interact with the slow and janky batch scheduler every time you want to run a function, right? That's the whole cell. But MPI sort of breaks this in different funny ways. And I'll walk you through where it becomes difficult. So oftentimes when you want to run MPI functions, MPI applications on your system, this is one of the situations, right? You say, you get a batch job and you say, my batch job is 512 nodes, and I have this huge MPI application that says, run on top of this 512 nodes. You use MPI's internal mechanisms to connect them together into your communicator. You run your stuff. Parsl doesn't care about what stuff happens underneath, but as far as a system like Parsl thinks about it, you captured all 512 nodes and you want to run on that, right? It's a complete breakaway from the model where we get all the nodes, you put workers on them, and you send functions to them, right? It's a break. But then you think about the high throughput situation where you say, I don't exactly have like one giant simulation of the universe, but instead what I have is my LAMS or my NAMD or my molecular docking simulation. You're basically trying to say, I have an application that uses MPI, runs really smoothly on, say, 4 nodes, but I want to run a lot of simulations. And if you try interacting with the batch scheduler, you quickly realize that the batch scheduler doesn't like it when you try to pump, I don't know, 100 jobs into it, right? Some batch schedulers will limit you to, like, say, 10 jobs active at a time. So how do you do that? So you go to sort of like the pilot job model where you say, oh, I want to get the batch job. I would like Parsl to get that batch job of like 1,000 nodes, and I want Parsl or the pilot job model to take care of filling in that batch job with many of my 4-node MPI applications, right? That's oftentimes the model. That's what people expect to happen. Now, an interesting wrinkle happens here. In order to actually launch the MPI application, it's not as simple as just running a Python function. You need to actually use MPI exec or MPI run, srun, AP run, whatever is the mechanism provided by the system, the manufacturer, to basically set up the MPI context for you so that you can actually get your MPI application launched with the right number of instances in the precise shape you wanted, with the right GPU bindings and a lot of bells and whistles, right? And then you run into the other side of it, which is that when you run these MPI applications, some of them finish and the user expects you to backfill. Oh, now, my 4-node simulation finished quickly and I can run another one there. So you expect that batch job to be kept filled with such MPI applications. So now this is getting even more complex, right? Slowly. And then we come across this last situation, which is a little bit of a mess. So user comes to you with this request for provisioning 1,000 nodes, and you say, I have some applications which, let's say, it's a small simulation that requires 2 nodes, and in another situation, I might run into simulations that need 4 nodes, 8 nodes, or some arbitrary number of nodes. And now you have to sort of fit in arbitrarily shaped MPI requests into this bash job that contains 1,000 nodes. And that's sort of hard because until now, Parsl and the pilot job model assumed everything is uniform. You get resources of the same type. And then once you provision them, it's fixed, and then you send functions to it, right? Now here, you need to keep track of how many nodes are available in the bash job. What is running? How many resources are left over? Can I accommodate the shape of the specific application in that available set of resources? And so there's a little bit of like box packing going. 1 minute left. Oh, shoot, I'll run very fast. Okay, so the proposed solution here is to do this new experimental branch, which has the framework, the scaffolding of what MPI support is going to look like. So the first bit is you specify this resource specification dictionary that contains a few little tunables. Now, this is going to be parsed. If you say resource specification of like this many nodes, I want this many ranks, we will compose a prefix for you, which is going to match the language that your machine speaks. If it is MPI run, MPI exec, we'll put in the right prefix there for you so that then you can just plug in your application call. Again, this is not Python functions. This expects a bash application, right? You're calling out an MPI application at the end of the day. You have a few bit of tunables here. I need help from people to get a good feeling of what sort of things people expect to see when they want to run MPI applications. GPU pinning, accelerators, I don't know. What do you want? Tell me. And you specify at runtime, when you launch this application, you pass in the resource specification. So you can call any number of applications with the right number of resource requirements, and it'll be figured out in runtime. How does this work on the runtime? You set enable MPI mode is equal to true on the high throughput executor. You can forget the for part. You can specify a large number of cores just so that we provision lots of capacity to run your stuff beyond the number of cores available on it. And the last bit is that you need to shoot. It's not okay. It's lagging. Yeah. So you need to specify the simple logic so that we don't automatically go ahead and use the launcher and try to get your workers onto all of the resources. You just want to skip essentially that so that the launcher is left for the application to use. There are still a bunch of things that are wrong with the system, like limited in functionality. For example, what happens when something fails? How do we reclaim those resources? What sort of GPU binding do we need? I don't know. Please tell me what sort of stuff your application needs. There's a lot of discussion going on about configuration cleanliness. I would like it if people get more involved in that stuff. As users, we want to hear your thoughts on these things. Potentially a new MPI app instead of the bash app, Python app, a new type of app for specifically MPI stuff. And this is where I come back to the main point of the stuff, which is like, Uncle MPI really needs help. We need your help. So here are the things that you could potentially do. Read the MPI docs. I will share links to all of this stuff in the slides. There is an experimental branch which has stuff that you could actually try now. Tell us what worked versus what didn't. And if you have ideas of things that you would like happen, add an issue, add a PR.
On differentiation and migration, and finally expand this understanding.
Mute? Or is that a question that I'm misunderstanding?
Sounded like someone was delivering a lecture.
Cool.
Yeah.
I have a question.
And I'm going to stop there. Okay.
Any questions?
Yes.
In the past, I saw there was like an FBI executor. Whatever happened to that?
Deprecated and dead.
Okay.
That was quite different. That wasn't for running MPI tasks, like for running tasks on an MPI family.
Correct.
Okay.
Yeah, so just to echo what Yadu said, we've had probably 10 plus people ask us for MPI support in the last year, and we keep telling them Yadu's working on it. Now is the time to come back. If you've asked us for MPI support in the last year, please ping us. Yadu would love to work with you to try and get that sorted. And I also should do a big thanks to the Balsam team who have helped us with all the MPI side.
I should have called that out. Yeah, a lot of the functionality that has gone in, including the resource specification, the underlying prefix configuration, all of that is coming from Balsam. All right, thank you.
All right, thank you.